everyone, welcome back to yet another Euphoria Academia YouTube video. Today we're going to be doing the Physical Sciences Physics Paper 1, May-June 2023 paper, and this was for the grade 12s. My name is Ole. I'll be taking you through it, and we're just going to be doing electric circuits and everything electric circuits from multiple choice to the main question of the electric circuit. So without further ado, let's get into it. Alright, beginning with the first question, we need to understand what the question is looking for as well as understand what the circuit diagram is representing. So question 1.8 in the multiple choice, we have that in the diagram below, R1, R2, and R3 are identical resistors, meaning that they have the same resistance. The battery has negligible internal resistance. Hey, English is biting me there. But the battery doesn't have any internal resistance. So the current is going to flow from the positive terminal of the battery. It's going to move from that point through R1, and then it's going to split into this parallel circuit into, we'll call that I1, and that one will be I2, and it will rejoin into the main circuit, and we're going to have a total current. Alright, now the question is asking us the power dissipated by R1 is P. Which one of the following is the power dissipated by R2? Okay, so we already know that our power equation is equal to, I'm just going to use current in this case because I started speaking about current, I squared multiplied to R. Now, the question states that for the power dissipated by R1, that is just given as P, right? And we already know what P is equal to. It's equal to the above. All right. So what is happening in the circuit underneath? All right. So they want the power dissipated by the second resistor, so R2. Okay. Now the power dissipated is still equal to I squared multiplied by R, but this is going to give us a different type of I, right? Now, because we know that the resistors R2 and R3, they're identical, they have the same resistance. That means that current will actually divide itself equally. So that means a half of the total current will go to R2 and the other half is going to go to R3 because there's no more resistance or less resistance in one path, so it's just going to divide itself equally. So we can actually say that half of the main current, the total current, I'm not going to write I total for this one, is going to go into R2, going to square that, and the resistance, it's still the same resistance as the resistance R1. Alright, so that will give us, when we do maths, alright, when we square it as well as apply it to the half, we're going to get a figure of that. Alright, now we can see that at least that part is actually the power dissipated by R1, as you can see here, right? It's the same equation. So the answer to this one, or I guess to make things easier, if we just replace that with the P that we are told it is, then we actually get one of the answers which are given in the multiple choice, and that is letter A. Now getting to the meat of the question paper in terms of electric circuits. We're going to get to question 8, and question 8 starts with 8.1, which again is a definition, and ends with 8.4, and it is a total of 21 marks. So let us begin with it. As always, we have to understand what is going on with our circuit before we get to answering any questions, because I do believe that if you understand what is going on in the circuit, then it'll be easier for you to answer every and any question that might be presented. Right, so let us get into it. So we have a battery where we don't know the EMF, and we don't know the internal resistance, and it is connected to the resistors, of which we know their resistance, and a high resistance voltmeter is also connected. Always know that a voltmeter is of high resistance. All right, that's why we connect it in parallel. All right, two switches and two ammeters. I'm not going to say that word again, but their resistance does not matter. All right, so let us go into the circuit. So as indicated or as mentioned, the battery has an internal resistance of which we do not know, and it has an EMF of which we do not know, but alas, the current is going to flow from the positive terminal of the battery through the internal well, I guess fight against the internal resistance, then out of the battery, and then it's going to go into this branch, and then it's going to go through the 3 ohm resistor, and then finally join again like that. The other half of, not the actual half, but the other part of the current is going to flow through this branch, through the ammeter, through these two resistors, through the switch which is indicated as closed, through the 5 ohm resistor, and it's going to rejoin the other part of the current. Now as we move through resistors, note that there will be voltage drops, so the voltage will drop there as well as here, as well as through this resistor, and yeah, that ammeter reading is actually the total total current rather, right? And then the one read by this ammeter will be I1, and the current flowing through this branch will, let's classify it as I2. I total is equal to I1 plus I2. Yeah, I think we have a good understanding of what is happening here. So let us begin the question. All right, we're going to do we're gonna start with the question. Question 8.1 is asking for the definition or stating Ohm's law. So I'm just gonna write that, and you just need to mention like the keywords, but of course it needs to be English and a coherent English sentence. So just mention that the potential difference, right? Potential difference, and then we want to see directly proportional. Actually, let me just write that sign. So let me just remove that. In fairness, I could have written the whole word, but okay. Directly proportional to the current, and then it needs to be under constant temperature. All right, so that's not me writing, even you of course have to write it in full in the exam, but these are more or less the keywords that the examiner might be looking for. All right, let's get into the calculations of things. So 8.2.1 is asking for the reading of the voltmeter, but in this case we have another switch that has been introduced, which is switch S2. and this switch S2 is closed as well as switch S1. So that means we have that full circuit. So they're asking us to find the reading on the voltmeter, so the voltage across the 3 ohm resistor. Now to note, that voltmeter or that voltage reading that you're going to get is going to be the potential difference for the parallel circuit. Alright, because the potential difference is the same for every branch of the parallel circuit. So voltage is the same in the parallel circuit. Alright, so we don't know the current that's flowing through the 3 ohm resistor, but we do know the current that is going to flow through the 2 ohm as well as the 5 ohm resistor. Now they are in series. Alright, so we're going to have a situation where we can actually use Ohm's law, which is voltage is equals to the I multiplied to the R, and the I in this case is going to be the 1.5 that we are given, that is read by the ammeter A1, and that is going to be 1.5 amps, and that will be multiplied to the resistance of the two resistors, right? Because we're looking at the whole branch of this parallel branch in this case, right? To compute the voltage across this whole parallel circuit. So gonna have a situation like that: 1.5 amps multiplied to 7 ohms, and we're going to find that we're going to have a voltage of 10.5 volts, and this is going to be read by the voltmeter V. Alright, question 8.2.2 is asking for the reading on ammeter A2. Now remember, A2 is going to be reading the total current. Alright, so that's going to be our I1 as well plus our I2. Now at this point in time, we have I1, which is 1.5 amps, but from the previous question, we now know the voltage across the whole parallel circuit, right? So, and we also know the resistance. So we just need to find what our I2 is using our formulas, and that's going to be V over R, and that is going to give us the voltage. We found that as 10.5 over the resistance will be the 3 ohms that you see, and that is going to give us a current of 3.5 amps. So that would mean that the reading read by A2 is going to give us, let me just write subscript A2, is going to give us our 3.5 amps plus our 1.5 amps, and that is going to give us a total current through the whole circuit as 5 amps. Alright, question 8.2.3 is asking us for the power dissipated in the 3 ohm resistor. As covered before in the beginning bit of this question paper, we know that power is equal to I squared multiplied to our R. And in this case, we're going to use the current that is flowing through our 3 ohm resistor, and we found that to be 3.5 squared, and then the resistance is 3, and we're going to find that the power dissipated is 36.5 0.75 watts. Okay, for the following bit of the question, we are told that switch S1 is now open. So let us go open it. Switch S1 is now open. Okay, and then switch S1 is now opened while switch S2 remains closed. The reading on ammeter A2 is now 3.64 amps. Calculate the EMF of the battery. Okay, cool. Okay, so what is happening when switch S1 is open? We essentially don't have a parallel circuit anymore, and we have a normal circuit because the current is just going to flow from the battery through that resistor, comes out, and then will flow into it. And in this new situation where we have S1 being open, our ammeter reading on A2 is going to read 3.64 amps. 3.64 amps. So it will actually drop, right? But for question 8.3, we're asked to find the EMF of the battery. Okay, so the formula of EMF is equal to epsilon, which is equal to our total current multiplied to our external current plus our internal resistance. Now, in this formula, we don't know that one. We don't know what our epsilon is, and we don't know what our internal resistance is. So in maths, if you have two unknowns, right, something should be ringing into your head, like we need to do simultaneous equations, right? But we need to understand that we need to set up two equations right now. So how do we do that? Let us find out. All right. So one thing that we need to know, right, is that our epsilon and our internal resistance of the battery, it's something that is unique to the battery. It's a characteristic of the battery, right? And it will always stay the same, yeah, for the same battery. I don't mean that like the battery will not run out of energy. I mean, if you grab any 12-volt battery and it was constructed using the same things under the same conditions, it will always have the same EMF, right? So we know that no matter how we change the external circuit, our EMF as well as our internal resistance will always stay the same for the same battery. That is what I mean. All right. So in this case, we have two situations, right? So yeah, let me just write two situations. The first one, we have S1 and S2 closed. And then the second situation, we have S1 open, S2 closed. All right. So let us go through the first situation. First situation, we will have a parallel circuit, right? So we need to find the resistance. We need to find the resistance across the whole circuit. We need to now start taking things that we do know, all right? So the resistance across the parallel circuit will be the resistance at the 3 ohm resistor multiplied to the resistance of the 2 and the 5 ohm resistor over the sum of the resistance of the third resistor as well as the 2 and 5 resistor, and that will give us a replacement value of that's going to be 3. That's going to be 7 because 2 plus 5 is 7, and at the bottom we're also going to have 3 plus 7, and that is going to give us a resistance of 2.1 ohms. All right, cool. Now, initially, we knew that our current in this situation, when the switch S1 and S2 close, we knew that our current, or the total current, was 5 amps, right? So now for our equation, we have epsilon is equal to I, and then our R is okay, let me do the substitution already. Don't need to raise everything, but apologies. Our epsilon is equal to our I of 5, and then our resistance for the whole circuit is 2.1 plus our R. That is what we're going to call our equation 1. Now, when the switch S1 is open, what happens? Well, there's no current now moving through the circuit. There's no current, so the only circuit that we do have is when the current moves from the battery through the 3 ohm resistor and then back to the battery. Alright, and we're already told that our I has dropped, so even our resistance is just the 3 ohm resistor. Our current, as we were told, this is still our total current. They told us that it is 3.64 amps. So now our epsilon is going to be equal to 3.64 multiplied to 3 plus our internal resistance. That will be our equation 2. Now we're going to substitute equation 1 into our equation 2, and we're going to have a situation where we have 5 multiplied to 2.1 plus R is equal to 3.64 multiplied to our 3 plus our R, and we're just gonna multiply in the 5 as well as the 3, and we're going to find that we're going to have 10.5 plus 5R, and this is going to give us our 10.92 plus our 3.64R. Now we're going to find that our internal resistance is going to give us a value of 0.31 ohms, and then this answer that we have, you can basically substitute it into any of your equations that you created. So either 1 or 2, it's gonna give you whatever answer that you need. I'm just going to substitute it into my equation 1. So my epsilon is going to give me a value of 10.5 plus 5 multiplied to 0.31. I'm going to find that my epsilon is 12.05 volts, and these are your 2 answers. Right, now the last question, question 8.4. We are told that switch S2 is now opened while switch S1 is closed. So this switch is going to open and this one is going to remain closed. or from the previous question, I guess they're going to close it and then they're going to open the other one. All right, cool. The question asks, how does the voltmeter reading change? This voltmeter. So if this one is open already, we stop having a parallel circuit, but we have a current moving from the battery through these two resistors and then back to the battery again. So now we have a series circuit where everything is connected in series except maybe not the voltmeter. All right. So what's going to happen to this voltage or the voltmeter reading? Well, we're going to have instead of one voltage drop throughout the current, the circuit, we're actually going to have two voltage drops here. All right, so that means the potential being read at this point is going to be higher than the potential being read at this point. And now instead of um, it just dropping once, it's going to drop two times. Right? So the difference between these 2 points is going to be higher. So that means our V reading, our voltmeter reading, is going to increase. It increases, right? And we can see it now because, I mean, the resistance, as I stated before, goes from being the first resistance that we had was 2.1 ohms, and it will now go from that to being a total resistance of 7 ohms because that 2 ohm plus 5 ohm. All right, let me just write it there. 2 ohm plus 5 ohms. So the resistance increases. That's one reason. And then, well, we've spoken about the voltage, we've spoken about the current, what happens to, I mean, the resistance, what happens to the current. Well, we can still use our EMF equation, and that is still equal to I, big R plus R, and that is still going to be that, and that is going to, we're trying to find our I, and our resistance is 7 plus 7, 0.31, and we're going to see that our I is going to be 1.65 amps, and that's the lowest that we've had. So yeah, let me just say our I will decrease, and essentially when you look at the Ohm's law, you can actually see in this relationship that if the resistance increases, that means the current should also decrease. So for these reasons, the voltmeter will also increase, and also actually the internal volts, our internal volts will also decrease. So yeah, that's the question answered.